Okay, starting, buckle up. Alright, pretty cold, so we're bundled in. First one, which one does not represent a linear equation? Well, if we had the time, we could graph these, right? Create a table, get some points and graph. But as far as, hang on a second, my pen is not working. There we go. Okay, a little better. So if you did a distributive property here, okay, you don't have to. This would be the same thing as this. So this is a linear, right? You can recognize this because this is a slope, this is a y-intercept, so that would be a straight line. This is also a straight line, but for some reason they didn't write it in standard form. So in actuality, it would be better to write it like this. 2 to the second power is 4. So the same thing, I just, what do you call, change the order of the terms. Now you can recognize very easily that this is the slope, this is the y-intercept. This one, y equals, and again, remember a while ago, I told you that's just a lazy way of writing x over 5 plus 1 over 5. So they just combine the denominator. And we can go a little bit further, right? Because that's the same thing as 1 over 5x. So, right, plus 1 over 5. A little tricky, but, you know. So, again, straight line, this would be a linear like this. And this is not linear because it's x to the second power. So all you got to say is that this is the x here to the second power, which produces a parabola. Okay, definitely not a straight line. So that's the answer for number 1. Number 2, they're asking you in which interval is it decreasing. So think about here, right? Where is this decreasing using the x-axis? So I'm going to just trace this. So over here, obviously, oops, a little too big. Let me see. This one? No. This one? No. This one? They're all the same. All right, let me use that one. So over here, you'll notice that if you're looking at from left to right, it's increasing. So that's not the area that we want. So that's increasing, so we're not going to count that. This one, we want a section of the graph where it's decreasing, meaning it's going this way, and nonlinear, which means it's not a straight line. So something that's decreasing shows that it's decreasing and not a straight line. So the only section that shows that it's here, right here. So, and what is that interval? Well, it starts here at -2. So if you look at the bottom, it starts at -2, right here, and it goes all the way to 0. So in this section, in this interval, right, that function is decreasing, right, from -2 to 0. And you can see it from there. It's decreasing and nonlinear. And what's the multiple choice answer? B. 3, oh, this one, we're very much confident in how to do this. So y equals, and we need to find the slope, right? And if there's a y-intercept, right? Something over here. The cost to rent a paddleboat is $7. Initial fee of $7 plus $3.50 per hour. So you're gonna get, so there's something that's happening over and over and over consistently per hour, every hour, every hour, every hour. It's $3.50, and that's our slope, also known as our slope. So $3.50 or 3.5x plus, and what's that fee? $7. So you think about a graph for that, right? X and Y. This is the hour, and this is the total cost. Remember, at 0 hours, and you haven't even sat on the paddleboat, you're already down $7 in there. There's my $7. And then every hour after that goes $3.50, another $3.50, another $3.50, right? So let me just write 1, 2, 3. So this 7 is our y-intercept. And then this, the slope here, is $3.50. Every hour, pay $3.50. So you can look at it as that way. And the only one that looks like that is, and we already have, it's A. 4 is the same question, so I'm going to skip. I don't know why I did that. And then this one says, does this function here, does this relation represent a function? Not a linear function, just a function. Meaning, does every input, right, does every x value, does every input or x value have one output? In other words, one y value. Well, -4 has 16, and that's the only output that you get when you plug in -4. So check. -2, you only have one output with 4. Output that's 4, 0, you get 0, 2, you get 4, 4, you get 16, and 6, you get 36. Doesn't ask if it's linear, if it's a straight line, just, hey, is it a relation that every time you plug in -4, you only get 16? Yes. Every time you plug in 6, do you only get 36? Yes. In that case, this is a function. And that would be the answer here. Every input has only one output, right? So far so good, nothing crazy. 6. I'm going to have to translate this, so go back again to your 6th grade when you used to do a lot of these. Right, translate those expressions into algebraic expressions. So it says, and I'll do it, and even back then, I would tell the kids, just translate it in order. So the function is defined as multiply the input, again, input is known as x, by -3/4. So there we go, our first part of our equation. Multiply the input by -3/4, and then add 2. There we go. We're done. So now we can take that and graph. So I know it's a negative slope, right? So it's going to be a line, straight line coming down. The y-intercept is 2, so let me go here and put a little dot on 2. So that's our starting point. And then we can use this information, -3/4, right, to graph. So 3 is going to be our change in y, and then 4 is going to be our change in x, meaning going up and down, we're going to go 3, and left and right, we're going to go 4. So just make sure that you go left, right? So let's go from 2, we're going to go 1, 2, 3, and then 1, 2, 3, 4. So there's one of our points. You want more? Just do it again. 1, 2, 3, 1, 2, 3, 4. Going down, 1, 2, 3, and then 1, 2, and obviously going down, you're going to have to go the other way. So 1, 2, 3, 1, 2, 3, 4. And so forth and so forth. And that's more than enough for us to create a line and show this relation. And then let me graph a line. Okay. And here's my dots, my points. Now, and then I'm also going to show you again where you see that. So if you think about it, the height, this distance here, I'll change colors. I'll make a little triangle out of this. Right, so if you think about that, if you count 1, 2, 3, there's 3, right? And there's my 3, the change in y value. So up and down, the height is 3, and then going left and right, what would be the distance? Well, 1, 2, 3, 4, and that's where 3/4 shows up. And if you do it again on the next point, look, 1, 2, 3, again, you get 3 going up and down, and going right, 1, 2, 3, 4. So there's my 3/4 again. Again, 1, 2, 3, and then 1, 2, 3, 4. So again, my 3/4, that ratio, right? So from changing y, changing x, it's always going to be 3/4, 3/4, 3/4 between any 2 points on the graph. Yeah, that's it. And then you can graph it. Put arrows, give it a nice, pretty name. This line is called y equals -3/4 x plus 2. Great page. 5, which one is a linear function? So again, going back to the one of the earlier questions, well, this is to the 3rd power, not a linear function. That's not going to produce us a straight line. This one, right? So let me write that. Y equals 1/6x. Definitely a linear function. This one, x is the exponent, right? So this one is obviously, no, that's an exponential function, by the way. And this one, x or the r, our variable, is to the 2nd power, so obviously no too. So the only one is this one. Which set of ordered pairs x, y could represent a linear function? So we want a linear function. not a function. So here there was a little problem in class. So if you look at A, negative, so if I, negative 2 is the input, 8 is the output, so negative 2 and 8, 0 and 4, 2 and 3, 4 and 2. So this looks like a function. Let me just do that, a function. B, 1 gives me 2, 1 gives me 3, 1. So the input of 1 has so many outputs, 4 different outputs. So that's not even a function. So that's out. C, negative 2, you plug in negative 2, you come out of 7, 0, you get a 12, 2, you get a 17, 4, you get 2. So this is a function. And then last one, D, 3 gets 5, 4, 7. Then 3, notice that 3 repeats, right? You get 5n now. So that's not a function as well. So that's true. But now, between the two, I got to figure out which one is a straight line. So you know what I'm going to do? I'm going to write those two as a table. So we got negative 2 is 8, 0 and 4, 2 and 3, and 4 and 2. Right? And the other one is negative 2 and 7, 0 and 12, 2 and 17, 4 and 22. Right, so they're both functions, but one of them is a straight line. So the other one could be a parabola. So let's find the change. So from 8 to 4, if you were to walk from 8 to 4, you would go negative 4. From 4 to 3 would be negative 1. And from 3 to 2 would be negative 1. On the other side, from negative 2 to 0, you would walk 2. From 0 to 2, you would walk 2. And from 2 to 4, you would walk 2. Now, let's take these two guys over here and divide. So if I divide negative 4 over 2, I get negative 2. Let's take the next one, negative 1 over 2. If I divide negative 1 over 2, I get negative a half. Notice that my slope is not the same. So this already is not a linear function. But let's look at this guy here. From 7 to 12 is 5. From 12 to 15 is 5. From 17 to 22 is 5. On the other side, 2 to 0 is 2. 0 to 2 is 2. And then 2 to 4 is 2. Pick any pair, right? This one was this one, for example. And if you do changing y or changing x, right, we subtracted the y. So we did y2 minus y1, x2 over x1. So we get 5 over 2. Look at that. So our slope is 5 over 2. Well, let's do the next pair. This 5 and this 2. Notice that they're exactly the same. That's also 5 over 2. And then if you did the last one, guess what? You would also get 5 over 2. So definitely the answer, and I didn't read this correctly in class. I forgot the word linear. So the actual answer is C, and C only, not A and C. Okay? That's a pretty nice question because I totally messed it up. So let me graph this like that. And let's say I had a line that go like this, and then I had another line that went like this. And I said, which one is increasing faster? Well, you would obviously say that one. So visually, super easy to say the blue line, right? But in here, problem with this question is that I don't have both on the graph. I have one of them on the graph. So what you can do is maybe just graph this, like one function A, put it on the graph. So function A, let me put that on the graph. 1 and 5, 1 and 5. 2 and 7, 3 and 9, and I'll do one more, 5 and 13. Well, I'm not going to do that one because I don't have room, but I'm going to connect these two dots, connect the 3 dots. Just move it over a little bit, and then you can tell me, and I'm going to stretch the other one, right? I'm going to stretch the other one manually. So which of these is rising faster? It looks like function B, right? Visually. Now, okay, what I also am going to do is I'm going to find the slope. Let's do the slope for function A. So this is A. Let me write those numbers again. 1 and 5, 2 and 7, 3 and 9. Let me write in line here. Right, this is function A and this is function B. Sorry, backwards. This is function B This is function A. 5 and 13, 6 and 15. So let's find the change in y. The change in y would be plus 2. Here would be plus 2. If you took plus 2, plus 2. On the other side would be plus 1, plus 1, plus 2. I apologize. This is not 2. This is 4. And this is 1. So notice that if I take any of the pairs, this guy with this guy, I would get this change in y is 2. The change in x is 1, so my slope is 2. If I took this guy and this guy, it would also give me 2. So the slope for function A is 2. The slope for function B, and in function B, you know what, let me erase this because I think it might be confusing. So function B, let me find the slope. And to find the slope in function B, you pick 2 points. I don't know, let's pick this one. So let's do B over here. Function B, I get a point, that's the point 410. And you pick another point, 1 and 1, pick 2 easy points. Doesn't matter which point you use. And if you did slope y2 minus y1, etc., right, so this is my x2, y2, this is my x1, y1. You're going to get 10 minus 1, and then 4 minus 1. And notice that 10 minus 1 is 9, 4 minus 1 is 3, and my slope is 3. So function A, which is, function B, which is this line over here, is growing faster. Okay? Because the slope is 3, and this one, the slope is 2. All right, same question as before. Where is this function increasing? Well, there's 2 areas where it's increasing. It's increasing here, right? You can clearly see it's increasing, and it's increasing here. So what is that interval? Well, if you look at the x-axis, right, look at the x-axis, it's increasing from here, from this section to this section right here. It's increasing, and it's increasing from here to here. And what are the values? Well, here is -4, and it stops at -2 because then it starts decreasing. And then here at 0 and near to 2. So these are the 2 sections where it's increasing from -4 to -2, and then from 0 to 2. So it looks like B is my answer. Let me just move it. I can't see. Yep, that's my answer. All right, so now here again, for this one, all right, this is my X and this is my Y. It says 5 goldfish is $1.50, 10 goldfish is $3. So we need to find the change. How is it changing every time you buy a goldfish? Well, you want the unit rate, right? So you can pick 2 points. Let's pick 0.5 and 150, and then another one 0.10 and $3. And you can find the slope or the change, right? That's going to give us the change. So slope, let's do x1, y1, x2, y2. 3 minus 150, 10 minus 5, so we get 3 minus 150 is $1.50, and then 10 minus 5 is 5. And if you divide $1.50 by 5, you get 0.3. So each goldfish, so if I could add to my graph here, so I can say 1 goldfish is 30 cents. So how is it changing here? Every time you buy a goldfish, you add 30 cents. Okay? The only one that makes sense, because the other one doesn't. Okay? The other ones don't. Which graph below represents a function? You can use the vertical line test here. Get a straight line. And I'm going to move this around. So as I move this, notice that my vertical line only touches the line in one location. It only meets. There's only one point of intersection. So that's a function. B is also a function. They only meet at one point. C, which is this guy. Now notice that C, it fails the vertical line test because right here I have 2 points touching the purple line. So fails the vertical line test, and as well as here. D is a function. right? That's the absolute value function. So the only one that fails the vertical line test is this guy here. So this is the one that's not a function. All right, not a function. Clear page. All right. Maybe I should make this smaller. Can I make this smaller? I can't. Right here. A little smaller. One. Okay. 13. Which represents a relation. That is not a function. Which one of these are not a function? Well, if you look at Q, I only have none of my X values, none of my inputs repeat, so every input has one output, so that's okay. R, none of my X repeat, so that's okay. I have S is okay, but T, I have repetition here. So 3, when you press 3, you get 4, which is okay. When you press 4, you get 5, but then when you press 3 again, you get negative 4. And when you get press 4, you get negative 5. So the input 3 has two outputs, has a 4, negative 4. And the input 4 has two outputs, a 5, and negative 5. So this one is not a function. (14) We have two functions. Function B is described here, but function A is given. It's given to you written, right? So we got to change it. And let me just write. So function A, and I'll write A over here, is the value of y is 2 less. So 2 less than 4 times the value of x. So remember that less than is a turnaround word. So in actuality, this is going to be 4x minus 2. We got to change the order of the term. So that's function A. Now write it over here. Right? Function A, erase that. And in function A, we know that the slope is 4. It's a y-intercept of negative 2. Right, so let me put that in a fake setting. I go bowling, and every game is $4. So 4 times, this is the number of games. So one game would be $4. 2 games would be 4 times 2. But then what does this negative 2 here, minus 2, represent? Well, that means that maybe I have a discount. Pay $4 for all the games that you're going to play, and then get a $2 discount. So if I play 5 games, it'd be 4 times 5, 20, and then I get $2 discount, my total would be 18. So you can think of it in that context if you like. Anyways, and then what do we want? Compare this rate of change. So right, the slope is our rate of change. Which function is true? Well, let me find, what do you call, the slope for this one. Okay, so for function B, pick any two pairs. So negative 9 to negative 5. To go from negative 9 to negative 5, you walk 4 positive steps. You walk to the right. Yes? From negative 3 to negative 1, you walk to the right, which is 2. So let's take those two and divide. So change in y, the difference between the y values is 4, and the difference between the x values is 2. So 4 divided by 2 is 2. So the slope for function B, m, is 2. For the slope for function A is 4. So now let's read it. Function A and B have the same rate of change. Nope. Function A has a greater rate of change than function B. Yes, the rate of change is 4, and the rate of change here for function B is 2. So that looks good. Function A and function B have both negative rates of change. Not true. This is a positive 4. This is a positive 2. And function D has a negative rate of change. Well, I'm not going to even read the rest. So B is the correct answer. 15. Which one represents a linear function? Remember, let me take out this guy. That's to the second power, right? It's raised to the second power, so that's automatically a no. This one, the x is in the denominator. So we talked about that on Friday. That's also a no. This one, the x is under the cube root. Also a no. And the only one that looks like this, right, linear, is letter D. So that's our winner. 16. Which one represents a linear function? Okay, so again, not just a function, but a linear function. So we're going to have to do a little work here. So let's go from 0 to 1 is 1. From 0 to 1 is 1. From 1 to 16 is 15. And then from 1 to 4 is 3. So already you can tell that if I divide this guy by this guy, right, the change in y, I don't get the same slope. So A is definitely out, because 1 divided by 1 is 1, and then 15 divided by 3 is 5. So A is out. B, let's just do a couple of them. 1 to 3 is 2. 3 to 9 is 6. And then on the other side, 0 to 1 is 1, and 1 to 4 is 3. So again, take this, right, the y difference, and divide it by the x. So 2 divided by 1 is 2. 3 divided by 6 divided by 3 is 2. So that looks good. And then let me do one more. 9 to 11 is 9 to 20 is 11, and 4 to 9 is 5. And if you divide 11 divided by 5, do you also get 2? No, so B is out. Look at this one. From 0 to 2 is 2. From 2 to 8 is 6. From 8 to 18 is 10. Okay. X values 1, 3, and 5. 2 divided by 1 is 2, good. 6 divided by 3 is 2, good. And 10 divided by 2 is 10 divided by 5 is 2. So this one is because all our change rate of change are the same. So another thing you could have done is look here. How do I get from 1 to 2 times 2? I'll put it times 2 over here. How do I get from 4 to 2 times 2? How do I get from 9 to 18 times 2? That's another way you could have done to find if it was linear or not. So this one, right, and I'll go back here. When you found the slope, right, no matter which point you use, you always got 2, so C is the correct answer. I'm not even looking at D. A crane is lowering a concrete block from a height of 270, and it's lowering. Okay, so if it's lowering, we know that the rate of change, our slope has to be negative. So let's put this like this, just to see, understand. This is my y, this is my x, this is my time, this is my height. So where does a crane start? Well, this concrete block starts over here, and every second it loses a little bit of height, right? And it goes that way. So we know our slope has to be negative. So 270 is not our slope. That's our y-intercept. So the fact that this is multiplying 270 times x, that's already out. B is out because although the slope is correct, it should have been negative, not positive. The block is not going up, so that's out. D is also out because look, the slope is positive, so that's also out. And the only one that makes sense, although it's not written in the format that we like, should have been written like this, right? It's losing 2.5 feet per second, and where did it start? At 270, so that's the only one that makes sense. Which one represents a function? Well, 2 gets 7. All right, already letter A is out, because when you input 2, you get 7 and 8, so that's not allowed. B, also out. The input of 3 has an output of 2, 3, and 4, completely out. C, when you put a 4, you get a 1, that's okay. 5, you get a 1, but then get a 4, you also get a 4. So the input 4 has 2 outputs, 1 and 4, so that's gone. So just by choice, it's that one, and you can always double check. When you plug in the 5, you get a 6, great. 8 has an input of 6, 9 has an input of 6. It doesn't matter if they share the same output. That does not matter. Okay, every input has one output. So anytime you put in 5, you will always get 6. Put it in the mapping diagram. Every time you press 8, you will always get 6. That's fine. And every time you press 9, you will always get 6. That's also fine. What is not a function? Which one is not a function? Well, this looks okay. B, 2 to 0, 4 to 1, that's okay. We don't have repeating inputs, so look for one that has repeating inputs. -1, that's okay. This one has a repeating input, yes, because you see 3 twice here and here. So when you plug in 3, you get 0, but when you plug in 3, you also get -4. So this is the one that's not a function. All right. So this one says, find one that matches this description. All right, so it says A, it's increasing and linear, meaning it's increasing and a straight line from -5 to -3. So from -5, remember, here's your x-axis, here's -5, here's -3. So from these two, between these two values, it should look like that, going up. Well, A is okay, B is okay, C is okay because they're all going up, and this one C, this little C here, looks okay. So all of them so far so good. It remains constant when the value is between -3. So between -3 and 0, the speed is not increasing or decreasing. It's constant, meaning it's the same. So B, look at here. It was, sorry, A was increasing. I'll put a little line, and then same speed, so that's okay. B was increasing, and then it was decreasing. So B is gone. C, it was increasing, and then it's constant, right? Same speed. D is increasing, and then same speed. So far, A, B, and C is good. And then it's decreasing and linear. So between 0 and 3. So between 0 and +3, it has to be decreasing and a straight line. Okay, so look at A. From 0 to 3, is it decreasing and straight line? Yes. So far, A is good. C, from 0 to 3, is it decreasing? No, it's going up. So gone. D, from 0 to 3, from here to here, is it decreasing in a straight line? Yeah, so far we have A and D that we have to worry about. And then last one, from 3 to 5, so look at your x-axis, right? So 3 to 5, here's my x, it should be increasing and non-linear. It should be increasing, going up, and non-linear, not a straight line. So we're looking at A and D now. So if you look at A, from 3 to 5, from here to here, it's increasing, but it's a straight line, so we don't want that one. What about D? Is it increasing? Yes, it's increasing. Is it a straight line? No, it's not. So here's our winner. 21. Car travels 36 miles in 45 minutes at a constant speed, so we know it's proportional, right? Car continues to travel at this rate. Which equation can be used to determine the total number of hours the car will travel in X hours? Okay, so let me try a graph here. So there's a point in this graph, and this is my, they want it in hours, so I'm going to have to make a little change, and this is my distance. So instead of 45 minutes, what is 45 minute terms of hours? It's 3/4 of an hour. Not even an hour. Let me take that back. So if this is 0, this is 1 hour, and this is 2 hours. 3/4 would be right here. In 3/4 of an hour, he traveled 36 miles. So we have a point over here. Okay. So how much? So we want this in terms of hours. Okay. So in 44. If in 36, 3/4 of an hour, which is 45 minutes, right? He drove 36 miles. What is, how much would he drive in 1 hour? That's what the question is asking, because we want the unit rate. So there's tons of ways of doing this. Is there an easy way of doing this? Well, you can do it with a tape diagram. You can change, well, let's write it. So let's write it as a rate. So it's 36 miles in 45 minutes, but I'm not going to write 45 minutes. You can write 45 over 60, if you like, which eventually simplifies to 3/4, right? So you can write like that. And then our goal is to get, hey, what about an hour? Well, if you did like a little tape diagram, you broke that into 4 pieces. So this is a full hour. Remember, 60 minutes, this would be 50, this would be 30, this was 45. So we know that in this amount of time, he drove 36 miles, which means 12, 12, and 12, right? If you split it up in sections. I mean, and then if he drove the last 15 minutes, would be another 12. So in 1 hour, how many miles does it go? Well, 12 times 4 is 48. So that would be one method you could have done. Or you could have found the unit rate. How do you do this? Well, you can put an x, you can cross multiply, and then get 48. Or you can do, hey, how do I get from 3/4 to 1 hour? Well, you divide by 3/4. 3/4 divided by 3/4 is 1 hour, right? Think about equivalent fractions. And then how do I, if I divide the bottom by 3/4, I divide the top by 3/4, and then I get 48. So again, tools from the past that you could have used to get this. Okay, if you didn't want to do that, another way of doing this, but the key here is rewriting 45 minutes as 3/4. Right, and knowing that it's a constant speed. If it's constant, you know it's a proportional line, so you have a line like this. And you're looking for this point right here. Let me put a question mark. Well, you could have done y equals mx plus b. Sorry, you could have found the slope first. Here's my slope. To find the slope, I need 2 points. So what are my 2 points? My first point is 36 3/4 of an hour, and the other point is 0, 0. Completely acceptable points, right? 2 points. y2 minus y1, so let's make these guys a 2. x2, y2. So we get 3/4 minus 0, 36 minus 0. And then we get 3/4 over 36, right? Which is the same thing as multiplying. It's a, what do you call what's the name? A complex fraction, right? 3/4 over 36 is the same thing as 3/4 times 1 over 36. Did I write this the wrong way? Yes, I did. Sorry. That's right. Apologies. The point is 3/4 into 36. That's my mistake. The other point is 0, 0. So I changed the order. I made a mistake on the order. So this is x2, y2. This is x1, y1. Apologies. Now it makes more sense. So 36 minus 0 over 3/4 minus 0. You get 36 over 3/4. And if you put that in your calculator, you eventually get 48. Remember, this is a complex fraction, so 36 times the reciprocal of 3/4 is 4 over 3, which would have gotten you 48. So the slope is, right, this missing number would have been 48x. And there's our answer. That took a little longer. Which one represents a function? Well, a is gone because the inputs repeat, right? The 2 has 2 outputs, 7 and 8, so that's gone. B is definitely gone. C is also gone. And D, well, there's 5 is unique, 8 is unique, and 9 is unique, and they all share the same output. That doesn't matter, so D is okay. 23, which statement explains the type of function that's represented by the equation y equals x squared plus 9? Well, let's translate this, right, to a sentence. How do we write that? The function is linear. Well, it's definitely not linear, right? It's to the second power, so it's not linear. So A is gone. Function is linear. Stop reading. The function is non-linear. Okay, I'm interested now because it contains more than one term. Absolutely not. And then D, the function is non-linear, correct, because the variable x is raised to the second power, and that's exactly what's happening here. So D is our correct answer. 24, which statements best explains whether these ordered pairs represent a function? The ordered pairs represent a function because no output values are repeated. Absolutely not. Ordered pairs represent a function because each output value is greater than each input value. Complete garbage. The ordered pairs do not represent a function because one input value has 2 different output values. No. Well, first of all, let's see if it's a function. I forgot to do that. -4, 6, -8, 9. So every input is unique. Sorry, it's not unique because 6 repeats. Look, 6 has 2 outputs, the 7 and the 9. So this is not a function. And it's not a function because one input the 6 has two different outputs. It has a 7 and 9, so actually C is the correct one. All right, so I forgot to see if it was 25. What is this? And then find one linear, okay? One linear function and one that's not linear, okay? One linear function right here. Linear. We have a slope of 2 and a y-intercept of 5, so linear. One nonlinear, well, that's right here. So the second one, nonlinear. Why? Because x is raised to the second power. Right? It's not going to produce a straight line. There, pick the easy ones. The rule for function is multiply the input by 2, then subtract 6. So the function, multiply the input or the x by 2, so it looks like this, 2 times x, and then subtract 6. Ta-da! The data set for the input values of x equals -1, 1, 3, 5. What value is one of the output values? So if these are my, basically, they're saying, hey, what happens when I plug these numbers in? So here's my x. I'm going to plug it down to the 1, 3, and 5. What are my outputs? So when I plug in -1, what would y be? Well, -1, so let's put it right here. 2 times -1 is -2, minus 6, -8. Let's do 1. 2 times 1 is 2, minus 6, -4. Let's put in 3. 2 times 3 is 6, minus 6 is 0. And let's plug in 5. 2 times 5 is 10, minus 6 is 4. So, which of these values, which value is one of the output values? So is -2 in here? No. Is -1 in there? No. It's 2 in there? No. It's 4 in there? Yeah, it came out here. So 4 is one of the output values in this particular function. 27. A group of friends went to the movie. Okay. They $15 per movie. So right there is our slope. Right, so instead of C, they're using Y. So C represents the total, the output, right? So group of friends went to the movie. So we know 15 is our slope. Our rate of change is 15x. I'm going to use x instead of n. And then plus, they all shared one popcorn. So 8.99. Look at a graph of this. This is the people that go to the movie. This is the cost. So think about this. Sorry, not people. Tickets. Notice that at 0 tickets, it's $8.99. Why is that? Because they bought a bag of popcorn, right? So even before they bought any of the tickets, at 0 tickets purchased, they're already down $8.99. So that's my starting point, my y-intercept. And then after that, it's going to be plus 15 for one person, plus 15, plus 15, plus 15, plus 15, right? And that explains this. So is there any equation that looks like that? Well, this is out because it's not $8.99 per ticket. This is also out. So it's either A or C. So this one looks very like what we have here. $15 times n, the number of people, plus your bag of popcorn. So 27 is A. 28, 2 order pairs, right? 2 order pairs. What is the rate of change? So the rate of change, the slope. Make this x1, y1, make this x2, y2, and then just substitute. 5, I don't know if you want to leave it as a fraction. I'm going to do it as a decimal. 525 minus 450 over 3 minus 2, right? So on the top, 525 is 0.75 over 1, which makes this, and again, right, 3/4, 3 over 4, if you change it back to a fraction. So the slope, m, is 3/4. Maybe this is too easy. 30. Section n, so we have something happening here. I don't know, but here. N, so first section is increasing a little, and then it increases a lot, right? The slope is much bigger, and then it stays constant, and then increases again. So in section n, the function is linear and decreasing. That's not true. No. In section P, right here, the function is linear and increasing. That's true. C, in section Q, which is here, the function is nonlinear. No, that's not true. It's linear because it's a straight line, so that's false. And in section R, which is this last section over here, right, this last line, the function is nonlinear. That's already not true because it's a straight line, so that should have been linear and increasing. The increasing part is true, but the nonlinear part is not true. So the only one that's true is B.